So before we get into 12.4, I want to tell you that in this section, we are no longer dealing with right triangles. You might want to make yourself a little note because we've been doing right triangles the whole time. Now we are no longer dealing with right triangles. Okay, so we are dealing with generic triangles. Any triangles with any angles. All you know for certain is that all three of the angles add up to 180. That's just kind of a universal rule about triangles, but we are no longer dealing specifically with right angles within right triangles. So we're going to start with this, finding the area of a triangle. So let's say we're given, any old triangle. Say it looks something like this. Just any triangle, no right angles. So we still label A, B, and C, and then you'll have side C, side B, side A. We've still got all that going on. If we want to find the area of this triangle, we need, the normal area formula. So area is normally 1/2 base times height. However, we don't have a height because it's this random triangle that isn't a right angle. So what we do is we drop down a vertical line that's perpendicular to side B, so it'll look like this, and then what you do is you end up making a right angle. So now we're going to kind of almost ignore, I guess, and take a look at what this triangle would look like. So we're going to label this H, and that's going to be the height of our triangle. Okay, so now all the pieces will kind of fall together from here. So if you're looking at this angle right here, and actually, let's maybe look at this triangle, the one on the left. So we know that the sine of A, and remember, sine, cosine, and tangent, we're talking about something that has a hypotenuse, and something that has a hypotenuse is only a right angle. So that's why we can only use sine if we're specifically inside of this right triangle here. So sine would be opposite over hypotenuse, that would be H over C. Okay, so what we're trying to do here is we're trying to make this area formula work, and the area formula doesn't work unless we know what H is. So this step is just getting us to figure out H. So we can take that formula that you've got right in front of you and just rearrange it to get H by itself. So we're going to do multiply both sides by C, like this. So now we know what H is. Okay, so this area formula right here is 1/2 times B. So B is still the base, so we're good there, but now H is C times the sine of A. So this portion right here used to be just an H, but we did a little manipulation with this triangle to figure out what H was equal to. So we've got that area. Now, here is the general formula that we can use. So the area is either equal to 1/2 B times C times the sine of A, or I could have done the exact same thing over here with this angle, C. I could have said the sine of C is equal to H over A, and A would have been the hypotenuse in regards to this right angle here. So we could have also said that we have, 1/2 times A times C times the sine of angle B, or it could have been 1/2 times A times B times the sine of angle C. So there are three different ways that we could have defined that area that I was just talking about. Okay, so it's all dependent upon which angles you have, what sides you have. So let's look at an example here. So find the area of ABC to the nearest tenth. So we've got this angle A, so that automatically tells us we're going to be using this first formula right here. And then we know side length B and we know side length C. So we're just going to plug it into this first formula. Remember, if you were giving something different, you could use either of these two formulas too. So the area, I'm going to write down the formula first, just 1/2 times B times C times the sine of A. And then we're going to plug in what we've got. 1/2, B is 18, C is 22, and then the sine of 31 degrees. Okay, so I'm just going to plug all of that into my calculator. Now remember, quick double check. You guys should always be in degree mode when we are doing this. Oops. Okay, so you can always just move your little cursor over here and just hover. And see, mine's in radian right now, so perfect example. So just to run you through this really quick, you may have to hit document, then settings, document settings, and then you can go and change the angle to degrees. All right, so I'd be happy to run you through that in class if you need to change it. So we do 1/2 times 18 times 22 times the sine of 31 degrees. And just plug that in, and we get about 101, and then let's go I guess this 9 would round us up to 102 because we've been rounding to the nearest tenth. So it's approximately equal to 102, and since this is meters, we have meters times meters, which would be meters squared when we're talking about area. So that would be your answer. So like I said, you could use any of these three formulas. It all depends on what they give you. So now let's take these area formulas. We're going to use them to develop what we call the law of sines. So start with the area formulas. So we know since they all give us the area, they must all be equal to each other. So we start there. Okay, so like I said, since we know they all give us the same thing, they must be equal to each other. So the first thing we do is we want to clear these fractions. So we're going to multiply everything by 2. Okay, so I'm going to take this whole thing, both sides, we're going to multiply everything by 2. And what's going to happen there is that 2 times 1/2 is 1. So we're going to lose all these fractions, which is a good thing. It's making everything simpler. Okay, so we know if that first line is equal, this next line must also be equal. And then what we're going to do is we're going to take the entire line, all three of those terms, and we're going to divide by the quantity A times B times C. All right, and you'll see what will happen. Like here, this BC will cancel with this BC, and all that's left is an A. So I have sine A divided by A equals, and then here the A and the C will cancel. This A and C will cancel. All I'll have is the B. So I'll have sine of angle B over side B equals, and then here I've got an AB that's going to cancel with this AB, and so I'll still have the C down below. So I have sine of C equals, and then I have a lowercase c down here. So remember, the capital letters are all the angles, and the lowercase letters are all of the side lengths. So this right here, this is known as the law of sines, and that's what we're going to be using for the rest of this set of notes. So this shows the relationships between all the sides of a triangle and the angles opposite of those sides. All right, so this note right here is supposed to go with this. It's supposed to say note. You can use the law of sine, so I guess kind of ignore that on the previous page. Note, that's what I meant to say right here, and then the lines got separated. You can use the law of sines in 2 different scenarios. The first scenario would be if you have 2 angles and any side. Two angles on any side. So you might have an angle, the next angle, and then a different side, or you might have 2 angles and the side in between. So the 2 scenarios, you've got angle, angle, side, or angle, side, angle. I'm sure you remember that those haunting phrases from geometry. It's a little scary in here. And then the other situation is if you have 2 sides and one of their opposite angles. So you have 2 sides and one of theirs, so you've got 2 sides in a row and then one of their opposite angles. All right, so that's the side-side angle case. So any of those 3 cases, we would be able to use the law of sines. So if we look, we're going to set up just a generic triangle for any of these. You don't have to be super particular about whether you're setting up the right angles and everything like that. So with this one, if we just look at a very generic triangle, NPQ, so we've got P, we have that. We have Q, and then if this is angle N, then what we have is side N. So these are the 3 things that we have. So this is an angle, side, angle situation. So the law of sines will work for us here. So I'm going to walk you guys through the basically 2 steps that we'll take. So step 1 is to find the third angle. So if you're in one of these 2 cases here, you have 2 of the angles, it's very, very easy to find the third. What you know is that N, P, and Q, they have to all add up to equal 180. So if you want to find N, all you do is you take 180 and you subtract the other 2 angles to see, what measurement is left for angle N. So for this, we do 180 minus P, which is 42 degrees, minus q, which is 65 degrees, and you can plug that right into your calculator. So you do 180 minus 42 for p, minus 65 for q, and that leaves 73 degrees for angle n. All right, so I'm just going to write the n again so I can box it up. So that is one of my measurements. And then just a side note for the directions, when it says to solve a triangle, it means to find all of the missing pieces. So I have 3 pieces given, that means I'm missing 3 pieces. So I just found one of them. And then step 2 is you want to use the law of sines to find the other 2 sides. Okay, so I have 2 of my sides. I'm sorry, I have 1 of my sides. I want to find the other 2 sides. So we set up the law of sines that we have, and the law of sines look like this. Sine A over A equals sine B over B equals sine C over C. So we're going to set it up for this particular one. So we've got sine n, and now we know n is 73 degrees, over little n, which is 5, equals sine P, which we know is 42 degrees, over little p, which we don't know, that's one of the ones we're trying to solve for, equals sine of q, which is 65 degrees, over little q, which we also don't know. Okay, so we're going to use the law of sines to find those other 2 side lengths there. So that's the equation that you set up. So start with like this one right here. If we start with that, we're trying to get p, so we are going to cross multiply both sides like this. So we will have p times the sine of 73 degrees equals, and then cross multiply here, and we'll have 5 times the sine of 42 degrees. And then you would just divide both sides by the sine of 73 degrees, and you will have p. Okay, so these would cancel, and let's walk you through the calculator. So set up a little fraction, and you'll do 5 times the sine of 42, and then over the sine of 73. Okay, so you just plug that in. We end up with about 3.5. We're always going to be rounding to the nearest tenth. So p equals 3.5. So now I'm just missing 1 piece. So now I can look at this relationship right here, because I just found p. I just figured out, let me label it in here, a different color. I just figured out that p was 3.5. So now I can do the same cross multiplying with this one. So now I cross multiplied these 2. So I get q times the sine of 42 degrees equals p, which is 3.5, times the sine of 65 degrees. Okay, so to get q by itself, all I have to do here is divide by the sine of 42 degrees. Okay, so these will cancel, and q will equal whatever I get when I plug this in. Okay, so set up a fraction. So we get 3.5 times the sine of 65, and then divided by the sine of 42. So about 4.7. Okay, so that is what it means to solve the triangle. It means you get all the little pieces. Okay, so if we are given 2 sides and one of their opposite angles, we get into this whole different category down here because we've got a lot of different options. I'm going to try to walk you through all these possibilities. So if you have 2 angles and a side, you only have 1 triangle. That's what we were just doing up here. If you are given 2 sides and one of the angles, you've got a lot of different options here. So let's look. One possibility is if A is acute. And now you're not going to have to memorize this chart or anything. I just want to kind of walk you through very briefly why you could potentially have 0, 1, or 2. So in this scenario right here, let's say that A is smaller than this measurement right here. If they give you this side length and this side length, and they give you this angle right here, so if this angle's set, then you know where this line is. This line is too short. You can't possibly make a triangle out of it. So that means you have no solution. Say this A is exactly as long as it's supposed to be, then you have 1 solution. Say perhaps that A is somewhere in between, then this is where you get 2 solutions. So these are the crazy ones. Like A could go here and land, or A could go over here and land. So you would have this triangle as one possibility, or you could have this triangle as a different possibility. Okay, or you have the possibility where A is even longer than B, which means it has to land over here, because otherwise if we put it over here, then it would go longer than B. And then if A is either right or obtuse, same situation. If A is too short, you can't possibly make a triangle out of it. And if A is long enough, then it will land right here and you'll get one solution. So this, again, you don't have to memorize or do anything with this chart. This is just to kind of walk you through your possibilities, okay? So since sine of A is equal to h over b, this kind of relates all this chart together, but we're not going to have to do this. This is just kind of an FYI sort of thing. You can use h equals b sine of A. So this is just solving for h right here by multiplying both sides by b to find h. Just so you ever need to in one of these situations, you could figure out what h is. But like I said, we're not going to be specifically using this chart. So let's look at some examples that we've got here. So the first thing that we do is we try to figure out what our missing side is, okay? And so when we are doing that, we're going to set up, or I'm sorry, what one of our missing angles is. So let me walk you through the setup that we're going to have here. So we start with, let me write this, like sine A over A, so just so we've got it on the same page. And now, of course, this just happens to be for a triangle that uses A, B's, and C's. You can see, obviously, it changes a lot. So our S and T, we have the sine of R, which is 95 degrees, over little r, which is 10. We set that equal to the sine of capital S, and then over little s, which is 12. So our goal here is to figure out what S is. And we use, again, the law of sines to do that. So we're going to do a little cross multiplying here. So cross multiply here, we get 12 times the sine of 95. And then cross multiply here, we get 10 times the sine of S. So first thing we're going to do is divide by 10. And then we'll get a number over here. So I'm going to plug this into my calculator. So 12 times the sine of 95, divide that by 10. So here on the left, I get 1.195. Since we're still in the middle of the problem, you don't want to round a lot, just quite yet. So you get the sine of S. So remember, what you do to get S by itself is you take inverse sine. So we are going to take the inverse sine of this number right here. And we get something that's undefined. When we get something that's undefined, like that, what that means is that there is no solution. Okay, so this is one of those scenarios where this side length was just too short and you couldn't actually make a triangle out of it. So first answer, we got no solution here. Next one, we're going to basically do the same thing. So sine of n is 32 degrees over little n, which is 7, equals, and now we're going to attempt to solve for p. And then we put the little one down here. Okay, so same opening steps. We're going to cross multiply. 4 times the sine of 32 degrees equals 7 times the sine of p. Divide both sides by 7 because we're going to try to solve for angle p. So plug this side in. So 4 times the sine of 32 and then divided by 7. That gives us about 0.303. So again, don't round in this middle step here. It is not time to round yet. We'll round our final answers. So now we're going to take sine inverse, and I'm actually going to paste this whole thing so I can make my answer super accurate. Okay, so I get 17.6. Now would be the appropriate time to round. Okay, so now here's the part that's going to seem a little bit complicated. So you guys know the other day when we did, where the sine and cosine are. So one thing you may have noticed is that we have these reference angles. And when you're in either the first quadrant or the second quadrant, sine is positive. In those two quadrants, sine is positive. So we actually really have two options. And the way you find your reference angle in the second quadrant is you do 180 minus the angle you just got. Okay, so it could be 17.6, but it could also be this. I'll show you. Sine of that actually comes out to be the same thing. So see how you get the exact same sign for this one and for this one? So it could also be 162.4. Okay, so if we look at what we have so far, this is feasible. These two could still fit in the same triangle and have room for a third. These two could not fit in the same triangle because they go over 180. So this actually is not a possibility for us. Okay, so we've just got this one value. So the next thing we're going to do is we're going to find our missing angle. Our missing angle M, remember you just subtract 180 minus N, which is 32, minus P, which is 17.6. So we get our missing angle. There's a lot of calculator work here in case you didn't notice. So M is 130.4 degrees. So that's our obtuse angle. And then finally we are going to solve for little m. So we solve for little m by setting up basically this equation, but with m's instead of p's. So sine of capital N over little n equals the sine of capital M over little m. And now we can solve for m. So we multiply, cross multiply here, we get m times the sine of 32 degrees equals 7 times the sine of 130.4 degrees. Okay, then divide both sides by the sine of 32 and we will have m. Okay, so these cancel, and finally we will get this value. So 7 times the sine of 130.4 over the sine of 32. And we get about 10.1 if we round to the nearest tenth. So that is that entire triangle there. All right, so now finally we are going to solve part C here. So part C, we start this off the exact same way. We start with the sine of A, which is 47 degrees, over little a, equals the sine of B over little b. So capital B is what we're trying to solve for here. We're trying to get one missing angle. So again, we start by cross multiplying. And then the next step would be to go through and divide by 15 so we can solve for b. Okay, now I'm going to plug this in. 18 times the sine of 47 and then over 15. So we get this value right here. So again, don't round in these intermediate steps. So you get about 0.878 equals the sine of b. And then we take sine inverse of this value. So to get the most accurate answer, let's just copy and paste this whole value with all the decimal places. So we get this. So we get 61.4. That's when you can round. So b equals 61.4 degrees. Or, remember, we could have another angle with this as a reference angle, so 180 minus that value. And you could also have 118.6. Okay, so two options. So now let's look. These two don't go over 180, so this is a possibility. And actually these two don't go over 180, so this is a possibility. So this is that weird case where you actually have two possible triangles that fit all of this information right here. Okay, so we're going to separate them out. So my first situation is when I get this for B. I'm going to make a second column for situation number 2, where B is this value right here. Okay, so for both of these, it's very, very easy to find the missing side. The missing angle. So 180 minus A, which is 47, minus this value of B, which is 61.4. So the missing angle, let's find that piece first. So in this situation, the missing angle is 71.6 degrees. And in this situation, it'll be much smaller because I don't have much left to go. A is 47, and then this value of B is 118.6. There's not very many degrees left. So yeah, it's going to be a little small angle like that, 14.4 degrees. Okay, so we're just missing one piece. Both of our triangles are missing little c, side C. So we use Law of Sines. So we do sine of A over A equals sine of C over C. And I'm actually going to set the exact same thing up over here. Sine of A over A equals sine of this other value of C over C. Okay, same next step. We're going to cross multiply. Okay, same thing over here. We cross multiply. And finally, in both of these situations, we divide both sides by the sine of 47. Okay, same thing over here. To get this c by itself, we divide both sides by the sine of 47. Okay, so we are going to plug all of this in. So these will cancel, and c is equal to whatever I get here. So fraction 15 times the sine of 71.6 over the sine of 47. So this c is about 19.5. Excuse me. And then here, same thing. These sine of 47s will cancel, and c is whatever I get here. So since my angle is smaller, you should expect the side to be smaller. Oops. Okay, so here you get about 5.1. So one thing that you can check on these is that the order of the angles, like here, A is the smallest angle, then B, then C, which is why A is the smallest side, then B, then C. They keep the same order. All right, so sorry that went just a touch long. We will finish that last remaining problem when we are in class together.